Okay, almost all the students is here. So yeah, everyone, good afternoon, and I hope you already got your midterms exam syllabus. I mean routine. So soon from 24 it will start. So we have around 1 week. Okay, it's okay. Let's see how much we can progress. Okay, so our today's part is it is the representation of the complex number. Okay, complex number, how we can represent the complex number in a plane, like we used to represent the number in like Cartesian plane, suppose 3 comma 4. Okay, when we learn the number, after learning the numbers, we used to represent in Cartesian plane, graph plane. Okay, so similarly here we'll try to represent the complex number in in a plane. Okay, the plane where the complex number can be represented is called Argand plane. Okay, so our this topic is Argand plane and polar representation. So we can see that a complex number, a complex number all we used to represent in z plus ib form, right? A complex number in z plus I a plus sorry z equal to a plus ib can be represented by a unique point a comma b. Okay, a is real part, b is imaginary part. Okay, so in the Cartesian plane, taking x-axis, we know this is x-axis and this is y-axis, right? Taking x-axis as real axis, and y as imaginary axis. So all the real part of the number will be putted in real line, and all the, I mean this x towards the x, and all the imaginary part of a complex number will be plotted on the y part. Okay, up or down. The intersection of the two axes, this point we used to call this origin, right? In Cartesian plane, this is called zero complex number. The intersection of the two axes is called zero complex number. Okay, the plane representing the complex number as a point is called Argand plane or complex plane. Like we learned Cartesian plane last time when we used to plot it. Okay, so how to plot? Plotting is very easy. Suppose we are going to plot 3 plus 4i. That means 3 is real part and 4 is imaginary part. Okay, I don't forget. I mean I forget now. So we'll plot 3 comma 4 like this: 1 2 3, 3 in real, and 1 2 3 4, 4 on the imaginary part. Okay, as simple as that. Whenever we'll get the complex number, we will write in a comma b form. This is called order pair. We'll write in a order pair form. Okay, and then we'll plot. So we know how to plot 3 comma 4. Similarly, look, minus 2 comma, sorry, minus 2 plus 3i. Whenever this number, that means real part is minus 2 and imaginary part is 3. So minus 2 means 1 2 minus 2 towards the negative real axis, that is x axis, and plus 1 2 3. Okay, so this is minus 2 plus 3i. Similarly, minus 3 minus 2i. Minus 3 minus 2i, how to put? Minus 3 means real part is minus 3 and imaginary part is minus 2. So minus 3 means 1 2 3 here, and minus 2 means 1 2. So minus 3 minus 2i will be here. Similarly, 4 comma minus 3i will be on the fourth quadrant. Like 4 is the real part and minus 3 is the imaginary part. Okay, so it is like this. Now after that you can ask me another thing, that how to plot 3 plus 0i. Suppose I'm plotting 3 plus 0i. So 3 will be 1 2 3 will be here, and 0, that means we don't have to go to imaginary part, right? Because imaginary part is 0. If you consider 3 plus 0i, you can see 3 is actually what? 3 is 3 plus 0i is actually 3, right? And 3 means what? 3 means that is a real number. So a real number also can be represented as pure real number. can be also represented in a Argand plane. Okay. Similarly, pure imaginary number means 0 plus 2i. Okay, here is no real part because it is 0, so 0 is here and 2i is here. Okay, so this is 0 plus 2i. So whenever it is purely imaginary number, it will be on y-axis, and whenever it is purely real number, it will be on the x-axis. Okay, so this is the only thing we need to know about the Argand plane. Okay, so let me know if you are having any doubt regarding the plotting. Okay, the plotting don't used to come. You have to we only need to know the concept. Okay, whenever we are saying that okay 3 plus 4i, so that the image should be clear in your brain that where in which quadrant this complex number is. Suppose minus 2 3i, in which quadrant? Second quadrant. Like this image should be clear. Okay, so plotting will not come, but plotting related question will come. So if anyone have any doubt regarding this plotting, or what is Argand plane, or what is the like any doubt, you can ask me now. Otherwise I will go to the next part. Any doubt? Okay, fine. Okay, fine. Next is representation of conjugate of z on Argand plane. So conjugate and modulus we learned last class, right? But we will learn how to I mean what is the representation of conjugate. Conjugate just we learn as a definition wise, right? That I told that any number take the change the sign of imaginary part, and that will be the conjugate of the that complex number. But what is the geometrical what is the geometrical representation or geometrical properties of that conjugate? So conjugate is nothing like this. Look, geometrically the mirror image of complex number z plus a z equal to a plus ib, okay, represented by the order pair a comma b. Okay, you can see here this is z comma z equal to a plus ib complex number, where you here it is represented as a comma b, okay, in order pair. About x-axis is called the conjugate of the mirror image of this point. Okay, mirror image of this point along I mean about x-axis will be here, right? A minus a comma minus b. If it is a comma b, the mirror image of p will be the here q a comma minus b, right? So conjugate of this one will be this point. So if z is a plus ib, conjugate of z will be a minus ib. Okay, so some one I guess who is was asking, Nadia, I guess she was asking that, sir, why it is minus? This is the reason why it is minus. Understood? We conjugate means the mirror image of this point about the x-axis. Understood? Suppose the point is real point is this. Okay, if you take the conjugate, what will be the conjugate? Conjugate will be this point. So look, the sign will always change. The point, if the point is here on the second quadrant, it is also a plus, because look, second quadrant the imaginary part also positive, so the conjugate will be negative. Suppose the point is on the third quadrant, the conjugate will be on the second quadrant. Okay, and if the point is on first quadrant, conjugate will be on the fourth quadrant. Okay, conjugate. So what is conjugate? Conjugate is the nothing but a mirror image of a complex number about the x-axis. So look, if z equal to a plus ib, then z I mean z bar, that is conjugate sign, equal to a minus ib. So this is the mm, um, I mean the plotting of conjugate. Okay, and what is the modulus? Modulus also we learn very much what it called. Um, Modulus also we learn as a definition wise. But what is modulus? Modulus means geometrically the distance of a complex number. You can see the complex number is here. P equal to P is a comma B. Okay, which is actually Z. The distance of this complex number from the origin is called the modulus. Okay, from the origin, the distance, this distance is called the modulus. And here it is represented by mod Z is equal to square root of a square. This is we learned last class, b square, right? This is the thing. So this is the representation of modulus and the conjugate in the in the graph, in the graph. Now we'll come to this point, that is polar representation of a complex number. What is polar representation? This is very new to you, so we have to learn this. Okay, still now anyone have any doubt regarding the conjugate and modulus? I don't think so. So let's maximize this image. Okay, so here few points we'll have to learn. Let the point P represent the non-zero complex number Z A plus IB. You can see in this plane, in this Argand plane, this P is representing the complex number Z, which is actually A plus IB. The point P is determined by the order pair, of the real numbers r comma theta. What is r, what is theta, I will explain later. Okay, called the polar coordinates of P. What is saying that the point P determined by the order pair r and theta. What is r? R is the distance of this point P. Okay, of this point P, that means the the complex number from the origin. The distance of the point P from the origin is denoted by r, small r, okay, which is actually modulus of Z. And if you join this line, okay, if you join this line from the origin, how much angle, positive angle it makes with the x-axis, is theta. Okay, so what is r, what is theta, is it clear? R is the distance of the point P from the origin. Okay, P means, P is what? P is nothing but the complex number. Okay, here is the complex number point, and the distance from the origin is denoted by small r, and the angle which it makes, the positive angle which it makes with the x-axis, is called theta. And this r and theta is the polar coordinates of P. Okay, we have a equal to r cos theta, y and b equal to y r sin theta. You can I mean, if you ask me, then I can answer. If you join this line, it will be a right angle triangle, right? If you join, where this is r and this is theta. Okay, so for this one I'm showing you a diagram. Wait for a minute. Okay, just check this diagram. I'm drawing this diagram here. If you join if you draw a perpendicular from P, okay, on the x-axis, suppose here. Understood? So now look at here. This is theta and this distance is r. That means the perpendicular, sorry, the hypotenuse is r. Okay, and it's saying this point P is denoting z. Z means what? Z means a plus ib. And what is the order pair of a plus ib? A comma b. If this point is a comma b, that means this distance is a and this distance is b. Am I clear? If it is a comma b, this point, that means this point along the x-axis, this is real x a, and along y-axis, that is imaginary part, that is b. So that means this point, this part, base is a and perpendicular is b. So in trigonometry, what is cos theta will be? Cos theta, we know cos theta means base divided by hypotenuse, right? What is base here? Here base is equal to a. And what is hypotenuse? R. Okay. So we have cos theta equal to a divided by r. Okay. Cos theta equal to a divided by r. Base divided by hypotenuse. So if you simplify this one, if you simplify, it will be a equal to r cos theta. If you just cross multiply, a equal to r cos theta. Similarly, sin theta equal to b by r. Okay, sin theta means we know perpendicular divided by hypotenuse. So if you simplify this one, not simplify means like it will be equal to r cos theta. Okay, so that's the thing from where this came. A equal to r cos theta and b equal to r sin theta. Therefore, we can write z equal to this. If you just replace a and b, we will get this z equal to cos theta plus I sin theta. This is the polar form of the complex number. This is the polar form of the complex number. Okay. And this is the polar form of the complex number. Okay, this is the polar form. The later is said to be the polar form of the complex number. Here, r equal to a square plus b square. Okay, we see modulus of z is the modulus of z. Okay, there is nothing. What is r? R is this square root of a square plus b square. Okay, if you're having doubt, you just do one thing: square and add these two. Okay, if you square and add these two, it will be a square plus b square on the right hand side. Okay, and left hand side, left hand side it will be a square plus b square, and right hand side it will be r square cos square theta plus r square sin square theta. This is sine, sine. On the right hand side it will be r square cos square theta plus r square sin square theta. Okay, so if you take r square common, it will be cos square plus sin square, which is actually 1. So r square equal to a square plus b square. So r equal to, you will get this. Okay, and theta is called argument of z, which is denoted by arc z. So this is the part which we learn from here. Okay, that any complex number can be represented in polar form if the complex number is like this, z plus ib. In the complex number form it will be z plus cos theta plus I sin theta, which is the polar representation of this. Okay, where r is root over h square plus b square, and argument sorry, and theta is called argument of z. Okay, now one thing I'll introduce, that is, sorry, here I missed the r. Okay, it will be r cos theta. Okay, z equal to r into cos theta plus I sin theta. That is the polar representation. So there is another one, Euler form. We can write like this. So next I'll principal argument of complex number. Next, principal argument of a complex number. For this, I want to show you some figure. So what is principal argument? Principal argument means, you can see, if a complex number, lying on the first quadrant, you can see what is the value of theta. Theta will be alpha. Okay, alpha means 0 to, between 0 to 90 degrees, that is pi by 2, right? Similarly, next, if it is in second quadrant, the theta is pi minus alpha, that is, this is pi. Okay, and if this is the angle, it will be pi minus alpha. Similarly, if it is in third quadrant, it will be alpha minus pi. So this is the angle alpha. Okay, minus pi, this is the minus pi, and this is the alpha. So we can use to say that minus alpha plus, sorry, minus pi plus alpha also. If it is in fourth quadrant, we can directly say it is minus alpha, because that is the negative direction of theta. So now this is the principal argument. Is okay, fine, it is not so important. We need to learn how to represent a, number in a polar form. For this, I should do one problem from the exercise. uh, Exercise 5.2. Page number 114. So page number 114, question number, let's do question number 3. Question number 3 is saying 1 minus I. We have to convert this number in polar form. So whenever polar form we have to convert, there is a sum. First we have to decide in which quadrant this number is. Okay. So can anyone please tell me in which quadrant this number will situated? A minus I, in which quadrant this number is? Anyone? I'm asking in which quadrant 1 minus I is lying. Fast, answer me. In which quadrant 1 minus I, this complex number is lying? Why there is no answer still? We learned this one in this part today. In this part we learn where to put. Look, 3 plus 4i will be first quadrant. Where? Because the real part and the imaginary part both is positive. If the real part is negative and imaginary part is positive, it is on second quadrant. Minus plus. Third quadrant minus minus. Fourth quadrant plus minus. You already learned this. Anyone? Yeah, fourth quadrant. Fourth quadrant. Why? Whenever the real number is there, write down the order pair. Write down the order pair. What is the order pair? Order pair will be, suppose this is Z, I'm writing this is Z equal to this. Order pair of Z is 1 comma minus 1. Okay, so this is in fourth quadrant. Okay, so first we have to know which quadrant we have this number is situating. Okay, so therefore Z is in fourth quadrant. Okay, first job. Second, we have to write this one as the polar form. What is the polar form? Polar form is Z equal to R cos theta plus I sin theta. We have to write 1 minus I is equal to Z. We have to write 1 minus I is equal to R cos theta plus I sin theta. We have to write, then we have to compare. Comparing both sides, we can write R cos theta equal to how much? 1, right? And R sin theta equal to, we can write minus 1. Okay, minus 1. Okay. So now what we have to do? We have to find the value of R. What is R equal to? Therefore r equal to, I told the formula. Or you can do like this. You can use the formula. I like to use the formula. Okay, do one thing. Whenever after this getting, you write down this one as a plus ib form. Okay, now comparing this one, a equal to 1 and b equal to minus 1. Now it's okay, fine. How to do? After that, after r cos theta and r sin theta, after you got this one, you can write by, sorry, by squaring and adding, we get, squaring and adding means squaring r cos theta and squaring r sin theta. So it will be r r cos theta plus r sin theta. Okay, and right hand side it will be 1 square plus minus 1 square. So it will be, next it will be r square cos square theta plus r square sin square theta, which is equal to 1 plus 1, 1 plus. So if you take the r common, what will remain? It will remain cos square theta and sin square theta, right? Cos square theta and sin square theta, and which value equal to 2. Then next line, r square theta equal to 1 equal to 2. So look, cos square theta and sin square theta is 1. So next line it will be r square theta equal to 2 and r square theta, sorry, r equal to, then what will be the value of r? It will be plus minus square root of, okay. Okay, up until this any doubt? Until this any doubt? Until this much any doubt? What I'm doing again, let me say, whenever you are getting the number, you just write down the in order pair to find out which quadrant they are. Okay, after finding that, you write down this one is equal to r cos theta and I sin theta. So then comparing both, we can compare the real part with real and imaginary part with imaginary part. Okay, so we got that r sin theta equal to how much and r cos theta equal to how much. Then squaring and adding them, we are getting this r equal to plus minus this one, but we'll take only plus. Why? What is R actually? What is R? I told, anyone remember? Please let me know what is R. Let me know what is R. I told once. What is R? Anyone? R is the distance. I don't have the diagram, so I'm taking this diagram. R is the distance of the point, of the complex number from the origin. So distance never be negative. So R value will be plus root 2, comma, write down R greater than 0. Okay, so to mention only. So R we got. Next, we have to find the theta. So what to do to find the theta? To find theta, we can do this thing. We have cos theta equal to how much we have? Cos. Okay, from where we got cos theta? R cos theta equal to 1. So cos theta equal to 1 by R. Okay, R value now put. Now put the R value. 1 divided by square root of 2. Right. So cos theta we got this, and similarly, if you find sin theta, you find theta, you will get sin theta value minus 1 by R, right? So it will be minus 1 divided by square root of, okay. Now so therefore, what is the value of tan theta? What is the value of tan theta? We know tan theta equal to this, sin theta by cos theta. So put the value of sin theta. Sin theta put the value, cos theta put the value. Okay, if you simplify this one, you can see that 1 by root 2, 1 by root 2 cancel, so it will be minus 1. Okay, so tan theta we got minus 1. Fine. So what will be the theta value? Theta we find here, theta is in fourth quadrant, right? We found here theta is fourth quadrant. Fourth quadrant, tan positive or negative? Fast answer. In fourth quadrant, tan negative or positive? Let me know. In fourth quadrant, tan negative or positive? Negative. Yes. This is very one simple, what do you call? One simple line. After school to college. So first quadrant all positive, second quadrant sign positive, third quadrant tan positive, fourth quadrant what positive? Fourth quadrant cos positive. That means in fourth quadrant tan is negative. So we can write minus 1 equal to tan pi by 4. Pi by 4 means 45 degree, and pi by 4 tan pi by 4 value is minus this one, right? So from here, what is the value of tan? We can get, we can write this tan pi We can write 10, 5, 5, 4. Okay. Because it is -1, so minus pi by 4, it is in fourth quadrant. Okay, so we can write like this. So what will be the value of theta? Therefore theta equal to minus pi. Okay, so we got theta value and r value. So our question was convert each complex number in polar form. That means we have to write the complex number in this form. So we have to write, look in here, what we r is there and theta is there, right? So we'll write here the polar form of, for first one, so I'm writing like very details, is r. What is r? R was square root of 2. Okay, square root of 2 in bracket cos theta. Theta means minus pi by 4. Minus pi by 4 plus I sine minus pi by 4. So this is the polar representation of this. Okay. Fine. Next, let's do question number 7. Question number 7 is saying, any doubt you can ask me, square root of 3 plus I. So whenever this number will be there, just write down the order pair. So it is order pair of Z is, so for you it will be helpful to understand. It will be square root of 3 common. So in which quadrant this number is? First quadrant. Okay. So if this is in first quadrant, therefore Z is in first quadrant. Okay, first quadrant. Next, we have to write this one equal to, write down this one equal to cos theta this. Okay, last time I think one thing was missing, that is r here is missing. Okay, if you multiply this r, it will be r cos theta and I r sin theta, right? I'm taking r common, so I'm writing like this. When you taking off the bracket, it will be r cos theta plus I r sin theta, right? So similarly here we are writing like this, r sin theta, r cos theta plus I r sin theta. So comparing this, I'm just copying from the this one, so like the thing is same. Okay, the thing is same. Comparing both sides, r cos theta will be here is square root of 3, and our sine theta will be 1. So by squaring both sides, it will be square root of 3. And it is minus 1 square. So square root of 3 will be, it is 3, and 1 square is 1. So you will get 4. Ultimately you will get 4 here. Next line, r equal to, will get square root of 4, which is equal to 2. You can write r greater than 0. Okay, until this same. And similarly we have to write this. Similarly we have to find this r equal to, one thing without this one, so r equal to, we will get 1 by sorry, cos theta will equal to, we will get 1 by r. Here r is 2, and sine value will be 1 by 2. Okay, check this one again. What I did, I just quickly I'm saying what I did. After getting this one, we just wrote order pair to find out the which quadrant they are. After which quadrant we find out, we write in this the given complex number in r cos theta plus I r cos theta sin theta form. After that we just comparing, and we squared the both side and add. Okay, then we find out the value of r, which is 2, and we know that cos theta equal to 1 by r. Okay, cos theta here will be root 3 by r, not 1. Here it will be square root of 3. Okay, because look, r cos theta equal to root 3, so cos theta equal to root 3 by r, which will be, which is equal to, root 3 by 2, and here r sin theta equal to 1, so sin theta equal to 1 by 2. So we already got theta, I mean z is first quadrant, that means theta will be in first quadrant. So what value of cos theta is root 3 by 2, and what value, if you put what value, it will give you 1 by 2. We can find out like 10 I did before. Okay, we can do like this also, or you can directly write that therefore theta equal to this, because we can understand this, this is 1 by 2 divided by root 3 by 2. If you simplify this one, 1 by square root of 3. Okay, which is equal to 10 square root 1 by root 3. 1 by root 3 means pi by 6, I guess. Right, 1030 value pi by 6. 1030 value is root 1 by root 3, right? So it will be 10 pi by 6. Therefore, which implies theta is equal to pi by 6. Okay, then similarly we have to write the polar form. I'm just copying this one. I'm writing the polar form of root 3 plus I the polar form is equal to r. R means we got 2 inside the bracket cos pi by 6 plus I sine pi by 6. So this is the answer. Okay, so I skip 1 and 2. That was very easy question, so I will skip this one. So, question number 1 and 2 of this exercise. I'm doing number 2. 1 will be homework. Number 2 is given z equal to minus square root of 3 plus I. What this question is asking? In this question, it is asking find the modulus and argument of the complex number. So modulus means we know, modulus means mod z. Okay, what is the modulus? Modulus is equal to mod z. Okay, if you remember this, I already showed this one. Modulus is this, mod z equal to a square plus b square. And what is the argument equal to? Argument equal to this. Where is the argument? Yeah, argument, I told that argument is theta. Okay, argument, it is denoted by theta. Argument z equal to, we can write this one. You don't have the inverse part, so I did not give in. Argument z equal to, we can write this. Argument z, which is equal to, we can write theta, which is equal to tan inverse. This is not in your, I mean, like, inverse is not in your part, so I did not mention. But yeah, we can write like this. Sine inverse of sine, tan inverse. Tan inverse this one, you can write that tan inverse Im means imaginary part of z. What is the imaginary part? You can see, look, sine theta. Okay, imaginary part of z will be sine theta, or you can say r sine theta. What is the real part of z? R cos theta. So r sine theta divided by r sine cos theta. R cancel. Sine theta by cos theta, how much? Tan theta. Okay, I'm showing you one more thing. That is, this is the rule. Okay, I did not give in because this inverse thing you don't have. What is saying? Imaginary part of z. What is the imaginary part of z? It is r sine theta, right? R sine theta. And what is the RE? RE means real part. Real part is R cos. Okay. So if you simplify this one, R sine theta, R cos theta, it will be actually a tan theta, right? R cancel, sine theta by cos theta, it will be tan theta. So it will be tan theta. Okay. So tan inverse and tan, it will used to be cancelled. So only theta will remain. Look, we write theta equal to this. Okay. So this is the proof. So whenever we have to find the argument, we can use this formula, that tan theta, tan inverse equal to imaginary part of z divided by real part of z. Okay, so we will use this one for this question. Modulus, so we know. Argument first, I'm finding the argument is this. Okay, modulus I am showing later. So it will be equal to tan inverse inside the bracket. What is the imaginary part of z? Imaginary part of z is 1 here, look, because 1 is what, I, so it is 1, and real part of z is minus root 3. Real part of z is minus root 3. So it is equal to this, which is equal to tan inverse minus 1 divided by square root of 3. Okay, which is equal to tan inverse, which value is minus root 3? You find out, it will be tan minus 1 by root 3. So 1 by root 3 means tan pi by 6, right? So minus tan pi by 6 means it will be minus pi by 6. It will be minus pi by 6. Okay, tan minus, in it can be in second quadrant or third quadrant also, right? So if you do like this, this will be tan 5 pi by 6. So this tan and tan inverse will cancel. This answer will be 5 pi by 6. Okay, so this is a little bit complicated one, right? You can do this way, another alternative way I'll show you later. Okay, for question number 1 I'll show you another alternative way. So how to find the z? I told that square root of a square plus b square, right? Square root of a square plus b square. So what is a here? Square root. What is a here? That a is minus root 3 square, right? Plus 1 square. If you simplify this one, it will be root 3 square, minus root 3 square is 3 plus 1, which is equal to square root of 4, which is equal to 2. So modulus equal to we got 2, and argument equal to we got 5 pi by 6. Okay, so I feel this is little bit complicated. So one easy method I am showing. Easy method, question number 1. Question number 1 is saying z equal to minus 1 minus I. Okay, you can do this question like the polar form. Okay, so we first will what we will do, we will write down this one equal to minus 1 minus I equal to r cos theta plus I r sin theta. Okay, then comparing both sides, r cos theta will be -1 and r sin theta will be also -1, right? R cos theta and r sin theta you can see. Okay, then we'll squaring and adding. If you square and add, it will be -1 square. Okay, which is actually 1. Both is -1. Oh, sorry. It is not. It is I root 3, right? Sorry, my mistake. It will be square root of 3. -1. The question is -1 minus I root 3, right? So it will be, yes, we have to add this. Sorry, this. So r cos theta equal to -1 and r sin theta will be minus root 3. So if you simplify this one, it will be this. It will be 4. So next line it will be r cos r square, because if you take r square common, it will be cos square plus sin square. Okay, so I'm not writing this one. I'm just putting dot 1 is equal to 4. So r value we will get 2 as r greater than 0. Okay, this is what we got. Then therefore cos theta equal to what we can write. We have this. We can write this, that cos theta equal to 1 by r, not 1 by r. Cos theta is equal to minus 1 by r here. Minus 1 by r. So r value we got 2. So cos theta equal to minus 1 by 2. And sin theta is equal to square root of 3 divided by. Okay. Can anyone tell me which quadrant the theta is lying? Theta for -1, comma, sorry, -1 minus 1 I root 3. In which quadrant theta is lying? Fast. In which quadrant theta is in? Please, everyone, anyone? In which quadrant theta is lying for this one? Third quadrant, right? Yeah, third quadrant. Theta is in third quadrant. So third quadrant tan is positive, we know, right? So tan value we got 1 by root 3. Okay, if you simplify this one, we will tan 1 by root 3. So we can write tan minus pi plus root 3, pi by 3. Oh, wait. Once again, here sin theta value is this. Sorry, this will be here. This will be here. Okay, cos theta value is -1 by 2 and sin theta value is this one. So answer is square root of 3. Okay, square root of 3. So we can write in third quadrant the value will be minus pi minus pi plus pi by 3. Okay, why pi by 3? Because look, root pi sorry, tan pi by 3 value is root 3, right? Now why minus pi plus root 3? Because look, when the principal value, check the principal value column, when it is the principal value argument of a complex number. In third quadrant, it is theta is equal to alpha minus pi. That means pi minus pi plus alpha. Alpha is what? The angle. Okay, so here what is the angle? Pi by 3. Okay, and minus pi, why? Because it is in third quadrant. Okay, last one, in fourth quadrant, when it is fourth quadrant, we used to write like this, minus alpha. Okay, in second question, in which quadrant this is was? In second quadrant, right? So in second quadrant, how we used to write? In second quadrant, we used to write pi minus alpha. Alpha is the angle, and argument is, principal argument is pi minus alpha. So look here, we wrote pi minus pi by 6. Okay, pi minus pi by 6 is pi by 6. Am I clear? 1 by root 3 is pi by 6 value, so it will be pi minus pi by 6. So this is the question. So if you simplify this one, this thing is important. Okay, we this principal argument, this one we need to learn carefully. It will be pi by 3. Yeah, if you simplify this one, it will be this. Therefore, that is, then it implies theta theta is equal to minus 2 pi by 3. Okay, so this is the value we needed, this to the value for the question number 1 and 2. So question number 1 and 2, I'm showing you in two way. I think the number first way is much more convenient for you. I mean, convenient means easy for you maybe. So you can use this first point, no problem. If you second one, we generally use for the competitive exam. Okay, look how easy. How, I mean, how like there is no, how simple this is. Okay, let's take. So we generally use this one in competitive exam. So okay, the thing is that our class is almost finished. Let's write down your roll numbers. If anyone have any doubt regarding any question, you can ask. Any question regarding doubt, you can ask. This is very important. This chart is very important. Principle of argument of a complex number. Okay, this will decide whether it will be what will be the argument of the complex number. Okay, so this principal argument is very important. Everyone write down your roll numbers.